Something important that I forgot to mention in the previous video. We were given this function and we were trying to understand this function here. From this function we managed to deduce this. We managed to deduce this. We managed to deduce these. And then we looked at we looked at f prime, and looking at f prime, it gave us this graph here. It gave us this graph here, and this function here turns out, well, this function here is an even function. So this function here gave us a graph looking like this. Well, this graph here is an even graph. This here is an even function. Remember what a function is. If you have a function f of x, remember an even function is when you input a negative x in there, and it makes no difference. The original function will stay the same. So if you look at this, this is our normal function. If you stick a negative version into here, if you put a negative version into here, negative x, and then you square it, it will become a positive. But then you got a negative. Well, if you put a negative into this thing here, it makes no difference to the original. What the point is that f of minus this, it becomes this. It makes no difference when you look at this here. Okay, so this thing here is an even function. Well, if you've got something that's an even function, then the antiderivative must be an odd function. If you have an odd function, then the antiderivative must be an even function. So in this case here, this is an even function. Therefore, our original function is an odd function, and it was an odd function because we sketched it and it looks something like this. This is an odd function. When you have something that's even, then the antiderivative must be odd. So you can use this as another piece of evidence. If you look at y equals y equals x squared here, the antiderivative of this must be an odd function, which it is in this case here. Okay, if on a separate occasion, if you have an antiderivative that's an odd function, let's say x to the power 3, then the antiderivative of this will be an even function, which is x to the power 4. So whenever you have an even function, then the antiderivative must be odd. So which is the case up here. Okay. So yeah. Okay.